I want to especially welcome all of you here to the lecture for today. By the end of this lecture, you should be able to interpret the mean and the standard deviation for a discrete random variable. You got to know what is a random variable. We shall look at that. You have to know the binomial probability distribution. When do you use it? Know the hypergeometric and Poisson distributions. When do you use them? Explain the covariance and correlation for jointly distributed distribution, discrete random variables, and then explain some applications. I'm going to make it quite brief and clear. So along the line, if you don't understand, please feel free to ask questions, because based on your questions, you will understand. Based on your questions, I will slow down. What does the word random mean to you? The word random, what does it mean to you? Who can tell me? The word random, it creates what idea to you? Who can tell me? Yes, Wallace.
Unpredictable connection.
Simple. Give a simple way of saying, explaining random to a 7-year-old child. Stella.
So not intentionally doing something.
Not deliberately.
Not deliberately, intentionally.
So that is random. What else? What is random? Just happening. Something happening. Yes, Vanessa.
So something that's not planned.
That is not planned. I like that one. I like Portia.
Was this I was about to say something you do without planning.
Okay, unplanned.
Yes.
So that is the idea of random. Now, a variable is anything. Okay, so a random variable is a variable that has possible chance of happening. And in a random experiment, when you see a lot of experiments, there are so many experiments, sometimes we call them even events. For example, playing a football is an experiment. Tossing a coin is an experiment. Rolling a die is an experiment. In any experiment, we have two kinds of random variables. The discrete random variable, as you can see, the discrete random variable comes with a singular number. So sometimes we say they have integers. What is an integer? An integer is a positive or a negative whole number. That's an integer. So discrete random variables are usually whole numbers, no decimals. That's why you see the bar as boom, boom, boom. But if you look at continuous random variables, they are decimals, so the bar is not boom, it's everything between the boom, boom, boom. So that's why you have several infinite distributions. Today we are going to look at discrete random variables. Next time, we'll look at continuous random variables. So let's start with discrete. A discrete random variable takes no more than a countable number. I've said it before. A number you can count easily. 1, 2, 0, 3, 4, 0, 5, 6, 0, and then on and on. Can you give me examples of certain things that are whole numbers, generally speaking? Certain things are generally whole numbers. Let's take an example. Who can quickly guess an example? Well, an example is, yes, Emmanuel.
An example can be age.
Age. Okay. Well, I will tell you for free that age is not really a discrete random variable. Why? Because a person can be 2.5 years. A person can be 2¼ years. So you can be 2 years, but you can also be 2½ years. That alone means that age isn't a random. Remember, it's a whole number. Steven.
Goal scored during a football match.
Goals in a football match. Okay, good. You can't have 1.5 goals. You can't have 1.6 goals. Very good. Let's take another one. Enoch.
Say number of people in the class.
Number of people in the class. Hey, why do you know? Very good. Very good. Now, let's look at a typical random variable that is discrete. Rolling a die. Rolling a die. Now, let's X be the number of times 4 comes up. Suppose I roll a die. How many numbers are in the die? There are 6 numbers. 6 numbers. So when you roll a die like this, you have 1, 2, 3, up to 6. One of them, now, if X is the number of times 4 comes up. So let's say that I roll the die once, but this time the question says roll a die twice. So if we roll a die twice, and X is the number of times 4 comes up, then it means that X could be what possible, number. The X, which is a random variable, could happen how many times? If you roll the die twice, how many times would you have 4 coming up? Possibilities. Steven.
Twice.
Sorry? How many times?
Twice. 2 times.
2 times. How many times? HP core. The possibilities, so HP core. Who is HP core? HP core, if you don't respond, I can't call you or rename yourself. So the rest of you will lower their hand. Stella.
Sir, 2 times. I agree with the person. Yes, sir.
Well, not exactly so. Not exactly so. Because there could be a first time you roll the die and 4 never come up. You can roll the die, 4 never comes up. You can roll the die, 4 comes up once. But you see, you can also, because the number of times you roll the die is twice, and you can roll the die twice. So twice means that you roll it the first time, 4 didn't come up. The second time, 4 didn't come up. So that's one option. You can also roll it again. First time, 4 comes up, but second one, 4 doesn't come up. That's another time. So 4 comes up only once. Or you can also roll the die, and in both 2 times, or in the 2-time cases, in all cases, 4 came up. So that is 2 times. That's twice. That's 2 times. So it's not only 2 times, but it can be 0 times, or 1 time, or 2 times. If you don't understand, you ask. Okay. So the number of times could be 0, 1, or 2. What if you toss a coin? You toss a coin. Okay. And then you toss the coin 5 times. And X is the random variable. Remember that this is a discrete situation. If X is the number of heads, and you are tossing the coin 5 times, what are the possibilities of X? What are the possibilities of X? Some of you have not named yourself, and when you have not named yourself, probably I can't call you. So please rename yourself and raise your hand. Yes. What are the possibilities of X? Andrew.
0, 1, 2, 3, 4, 5.
Exactly. So 5 possibilities. 0 possibility, 1 possibility, 2 possibility, all the way up to 5. Okay. So those are what we call, that X you don't know is the random variable. Okay. Let's compare that with a continuous variable. Continuous variable can take any value. Any value in the continuum, you can measure it. Who can give me an example of a continuous variable? Nobody should mention age. Because earlier somebody mentioned age. So I don't want age. A typical example of a continuous variable. Anastasia.
Salary.
Salary. Theophilus.
So, please, I actually wanted to ask a question. During the coin, I didn't really understand how like you get. So I was wondering if you could please like touch on that again.
Okay. So if you throw a coin, the first time you throw the coin, the possibilities are you have a head or a tail. So these are the possibilities. A head or a tail. Now you can throw the coin 5 times, okay? And we are talking about heads here. The first time you throw it, you can have tail, tail, which means there is no what? Head. So head is what? 0. You can have the second time, there will be tail, head. So head can appear what? Once. You can have another one where you throw it and you can have head. Head. Okay. You can have head, tail. And then you can have tail, tail. Okay, so let's look at it from this angle. This one will be better. So there will be the first situation where you throw it, there is no head. There will be the next one, you throw it, there will be a head. So you now have head appearing what? Once. And everything else, so this one where there is a head, okay, all the rest become what? Tail, tail. Tail, 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 tail. So there is no, the head appears only once. But I don't have to use this head tail. I just have to use a different one. So let me just show you a bit. So the first row, you can have a head. Sorry, you can have a tail. So there's no head. You can have the next one, there'll be a head. So head has come what? Once. You can have the next one, there will be a head. So now we have 2 heads. Okay, this one and then that one. You can do the next one, there will be a head. Okay. And then you can do the next one, there will be a head. And then finally you can do the next one. Is it 6? 6. That's 5. So you can see that, oh, and you do the next one, the 5th one, and then there will be, in fact, this one, there could have been a head. Okay, there could have been a head. Yeah. So in other words, you can throw the thing and all of them are head. That means that that takes this 5 heads. And you can throw the thing 5 times and 4 of them became heads. So out of the 5, 4 became heads. That is this one. And you can throw the thing out of the 5, 3 became heads. And you can throw out of the 5, 2 became heads. 5 times. Out of the 5 times, 2 became heads. And then you can throw out of the 5 times, only 1 was a head. And you can throw it in such a way that out of the 5, then none of them was a head. So the possibility of you having a head is 0, 1, 2, all the way up to 5. Okay. What's the name of the guy who asked the question? Does it make sense?
Yes, sir, please. I understand now. Thank you so much.
So examples of random variables. Somebody mentioned age long ago. Who can mention the other example? Rama.
Yes, sir. Time.
Time. Portia.
Say hi.
Height. Okay. The guy called HP Core. Can you rename yourself? Okay. Can you rename yourself? Or at least even mention type your name so that we know you. All right, let's go to Emmanuel.
I was going to say temperature.
Temperature. So these are some of the examples: the weight, the temperature, and then you have the time. I hope that you guys are not copying from here. You should be thinking. All right. Now let's look at the probability distribution of a discrete random variable. Now, before I tell you about it, I want you to understand something called distribution. What is distribution? The distribution is simply how things look like. How things look like. Now, if I were to ask you right now, majority of people who are starting first year university are around what age? In Ghana, the majority of people who are in first year university are usually around what age? Portia.
I would say 18.
Hey, we are sure.
Anne.
Good. Saibu, what will you say?
Say around 20.
Hey, that's now.
Say 17.
You say 17. Okay. So majority of them usually are around 18, 17, 18. Okay. 17. You see, what gave you that number is in your head, you have distributed it. In your head, oh, there is a distribution. There's a distribution. And that is what you just gave out. So when a random variable is discrete, okay, then one of the numbers you just gave, 70, if I pick a student and I close my eye, that student will represent the average, or the average number of height, age. And that is one of the possible values. You can pick another student who is rather 16 years. But when I started in uni, I was, I think I was 19. I think so. Because you have to wait 1 year our time. Okay. So that is, yes, let's now your hand is up. You have to wait. So the probability that a particular random variable takes a specific value is given by P of X. So remember that this X here is the actual value, one of the values there. So X can be equal to 18. X can be equal to 17. X can be equal to 19. So that is the probability that if I close my eyes and select a student, the chances that this student is 18 years is written as probability that X is equal to 18. So the way you're going to write it is probability that X is equal to what? 8. This is how it's going to be. However, if I pick for this 18, this single person, and I do another person, and I do another person, and I do another person, I'm no longer talking about a specific value. I'm talking about multiple values. So now you don't have a random variable representing a specific value, but you have a range of variables. So that range of variables can help you to know the distribution, okay, which comes from the word sort of a range. So you will know that, oh, majority of the students are between 16 years and 20 years. So the probability distribution here is the representation of the probabilities of all the possible outcomes. All the possible outcomes. That is what we mean by the probability distribution. It represents the probabilities of everything. And you can show that mathematically, graphically, or tabularly. You can show it using a table, using mathematics, or using graphs. We can look at them. Okay, so understand the difference between probability distribution and probability distribution function. Let's take an example. Okay. And we are looking at discrete variables, discrete random variables. Let's do an experiment where you toss 2 coins, not 1, but 2. And X is the number of heads. We are going to show the probability of, the number being X. So we're going to look out for all the possibilities. What is the probability? You toss a coin, okay? So there are 4 possible outcomes. The first outcome is, I remember there are 2 coins. So you toss the first coin, you get a tail. You toss the second coin, you get a tail. You toss the first coin, you get a tail. The second, you get a head. The first, you get a head. The second, you get a head. And then both of them, you get a head. These are the possibilities. So there are 4 possible outcomes of tossing 2 coins. Okay. How do we put this in a probability and in a probability distribution? So in the first scenario, you will notice that the probability that we have a tail, okay, here is 0. The probability that you have a head, but not a tail, or a tail, but not a head, is a second possibility. They are just 2. And then the probability that you have a double head is represented as 2. So this 0, 1, 2 are just what you might call denoting a nominal variable and coding it. So for example, suppose you're looking at sex and you have male and female, okay, or gender, you have male and female. When you are doing that, the male can be given a value of 1. The female can be given a value of 0. They don't mean anything. They are just representing the value. They don't have some intrinsic meaning like ordinal. That's what this one is trying to do. Now we have to find the probability. What is the probability of getting a tail? But the chances of getting a tail, you see, out of the 4, this happens only once out of the 4, which is 25%. Now, the probability of getting a tail head or a head tail is 2 or 4, so that is 50%. So you have assigned probability of occurrence for each of these random variables. And of course, the head is around 25%. So in any experiment, you can find the probability distribution of that. Now, these are discrete variables because you can see them as whole numbers. This can be represented as 0. The last one can be represented as 2. And you can draw it, okay? So this is a tabular form of displaying the probability, and this is a graphical way of displaying the probability. Now, looking at this distribution, okay, just look at the distribution here. You can tell me that which number occurs most of the time. Just looking, without even knowing what is on the left side here, just looking at the graph, which number occurs most of the time? Is it 0 or 1 or 2? Which number occurs most of the time? Vanessa?
1.
1. Why?
Because in the visual representation, it has the highest bar and it also occurs twice.
Very good. That's it. Now, as you can see, the probability must always add up to 100%. Or the probability is always between 0 and 1. Okay. You can see that here. And the sum of the probability is always 1. So if you sum all your probabilities and you don't get 1, there's an issue. You must always end up. But a cumulative probability function is giving us this. Okay. Is the probability of x being less than a specified value. Less than or equal to means that x naught can be part of those random variables. Let's look at an example of a cumulative probability function, not the normal probability function. Again, we toss a coin, we let a head be a head tail. Okay. The cumulative simply means that once you have the probability that we did, you are adding to it. So the cumulative probability function for 0 is 25%. For 1, you're going to add the 0.50%, 0.5 to the 0.25. And that will give you 0.75. And by the end of the last one, it should be equal to the sum. And the sum will be the same as the number 1. So cumulative is simply adding them as you keep going. Now let's look at some of the properties of a random variable, a discrete random variable. And there are 2 main properties of any random variable, 2 major ones, the mean and then the standard deviation, taking it. The mean and the standard deviation, or the mean and the variance, or the mean and the variance. So for all our random variables, we're going to look at the mean and the variance. The mean, the mean, the mean, the mean. The mean also has another name. It's also called expected value. Write that down on your kneecap because you might forget it in your day. The expected value is another name for the mean. And it is written as the expected value of x equal to mu, the Greek letter mu for mu. The expected value of x, which is mu, is the expected value, is the sum of the each, watch here, it is each random variable multiplied by its probabilities. Each random variable multiplied by its probabilities. So let's go back to our toss of a coin. Suppose you want to find the mean of this toss of a coin, and we know that the coin is a random variable experiment. How do you calculate the expected value? Remember, it says that take what? The probability multiplied by the random variable. So the probability is 0.25. That is a part that is here, 0.25. And then you take this 0.25, which is the same 0.25 here, multiply that by the x. Take the next one, multiply by the x. The next one. Do that, and then you sum them up. In this case, they will add up to what? To 1. When they do, that is the expected value or the mean of the probabilities. Fairly simple. It's not clear. Finding the mean is one thing. The most important thing is finding the variance. And just as I told you, the variance is simple. Watch it. If you know the mean, watch it here. If you know the mean, that's the mean from all of them, you can take each value minus the mean and then square it. Okay. Each value minus the mean, then you square it. Each value minus the mean, then you square it. Then one by one, you multiply the square value by the probabilities again. So when you are calculating the variance, you are multiplying whatever you got by the probabilities. And when you are calculating the expected value, you are also multiplying it by the probabilities. Remember, this is the random variable, the discrete random variable. Who is not clear? If you're not clear, let me know. I'll go over it again. Okay. Now, yes, Vanessa.
Sir, please, I'm not clear.
Okay, which part?
Everything.
Are you the one answering questions?
I know.
Yeah, the whole show.
Everything. There's a
Yes,
most.
how are you?
Pardon?
Your hand is up.
Yes, please. Please go over again.
Abrapa, you want to answer them?
No, sir. I'm also lost at the variance side.
Good.
If you can.
All right. It's just a matter of finding an example. So, let me see if I can get an example. I have an example, but I will just, normally example is more efficacious than present. Do you guys remember this one that we had? Okay. And you remember that we had the mean to be 1. Do you remember? Okay. So, to find the variance, all you have to do is create a column here. And that column should be the mean, each variable minus the mean. Remember the mean we had was what? 1. So we are going to take the x, which is 0, minus the mean, which is 1. You take the 1 minus the mean. You take the 2 minus the mean. That's what this one was saying. But look at the formula carefully. The formula says that you should square each one. You should square each one. So you're going to take each one, and then you square it. When you square, this value is -1. 0 minus 1 is going to be -1 here. So you want to square it, you get +1. So this one here is going to be +1. And I'm squaring x minus mu bar. So when you square it. Then you do 1 minus 1 is 0. When you square the 0, you also get what? 0. Then 2 minus 1, when you square it, what do you get? Who can tell me? You are squaring this one. What do you get?
1.
Exactly.
1.
You get 1. Now go back to the formula. The formula says that each one should be multiplied now by the probabilities. So you have the probabilities already here. So now you're going to take this one here, multiply by 0.25. What do you get? Okay. So what I'm going to write here is all of this x minus a mu squared multiplying the probability of the x. That's the last one. So you take this very one here, multiply it by the 0.25. What do you get? The first one. This one here, Anna.
0.25.
0.25. The second one, what do you get? Anna.
Yes.
You get 0. The last one, what do you get? Anna. The last one, Stella.
0.5.
0.25.
What do you get?
0.25.
When you multiply 1 by this, 0.25. So this is it. Then you sum them. So when you sum all these, what do you get? 0.5 what? Hannah.
0.5.
0.5. So that's it.
Yeah.
That's one. That's this whole formula here. That's this manya here. We just did. So the answer you're going to get is 0.5. That is the variance. Asam. Then the standard deviation, which is this one. Remember, the variance is this variance here is a sigma square. That's this formula. Then the standard deviation is when you have gotten this, you take the square root of this. So this standard deviation is actually the square root of this variance. So when you take the square root of 0.5, what do you get? When you take the square root of 0.5, can be, yeah, can be. What do you get? Stella.
0.707.
0.707. So this whole thing has been done here. I'm going to check it. See the final answer here. 0.707. So that is the standard deviation. Now, what is the difference between the standard deviation we found and then the variance? You can tell me, what's the difference between the standard deviation and the variance? Oh, by the way, those of you who said you didn't understand, do you now understand? The formula looked like Hebrew, but now do you understand?
Yes, please.
Very good. Nanaya, what's the difference?
The difference is just square root of yeah, it's just the square root. So for standard deviation, it's just the square root of the variance. So that's it.
What do they do? When I say the difference, what I mean is, what do they do? The variance is great. It tells you the dispersion of the data from the mean. how spread the data is from the mean. The standard deviation only standardizes that number. That's it. It standardizes that number so that if it is in any unit of measurement, the unit of measurement will not be. For example, when I say unit of measurement, you can have something like dollars, and you can have something like gallons, and you can have something like kilograms. All of them are in different units of measurement. The variance will suffer if the units of measurement are different. But the standard deviation standardizes the numbers to a common number that is readable. That's it. All right. You will learn about that in descriptive stuff. Yes, Stella.
So from what you're saying, that means the standard deviation just puts everything on the same level.
That's it.
If I'm right, okay, sir. Thank you.
That's it. For example, let's assume that somebody is in primary school and another person is in the university. And then you are told to check which of them is smart. Is it easy? No. Well, who can tell me why it's not easy to check which one is smart? Why is it not easy to compare them? Sarah?
So there are two different levels. There are two different things they are learning altogether.
Now, the question is it still possible to compare them?
With the standard deviation, I think so, yes, sir.
Like that. Yes, you can compare them. One of the things is that you will calculate the way the person in the university, their result. And you will also find the person in the primary school, the result, because they are results of calculating how smart they are. So let's say that this one result is on average 70%. And this one's result in the university is on average 60%. Then you can say that as it stands now, the guy in the primary school is smarter than the guy in the university because on average, compared to his peers, this guy is getting more percentage than the other guy. That's how. And what you are actually doing is you are trying to standardize something. So that is a standard. So this is it. You should be able to find the mean and the standard deviation of every discrete random variable. And that's what we just did. Next. Another random variable that we can look at is the binomial, because it also has a distribution. So another distribution or probability distribution function is the binomial distribution. The binomial distribution is a very powerful one. It's one of the discrete probability distributions. There's also the Poisson and the hypergeometric, as you can see. I want to look at the binomial. The word bi carries what idea? Bi, biannual, bilingual, binomial, bi. Amina? Two, exactly. So anything that is bi could be said to be two. That's how you have bisexual. All right. Now, when you have success, so these two, one of the outcomes of a binomial is success or failure. And guys, I don't want you to attach morality to the success. So when we say success doesn't mean that it's good, and failure doesn't mean that it's bad. For example, let's assume that I want to check the possibility of a person having cancer or not having cancer. If you don't have cancer, no cancer, okay, we use the word success. If you have cancer, you use the word failure. Now, I can still swap them and say that cancer is success and then failure is no cancer. So I just wanted to know that the success doesn't mean good, neither is a failure mean bad. So when one thing is success, the success is the one you are focusing on at that point in time. For example, yeah, the success is the one you are focusing on. So please note. All right. Therefore, we can represent the probability that a situation can be successful as P. This is binomial, don't forget. So the elements of a binomial distribution are quite an interesting element. The first one is the probability of success. The next one is the probability of failure. The probability of success is not the same as the probability of failure. The probability of success is P, and the probability of failure is 1 minus P. So it means that the probability of success plus the probability of failure equals what? It means that the probability of success plus the probability of failure equals what? Remember?
1.
1. Exactly. Now, there are other elements of the random variable, and so we're going to look at them. So let's assume that we have a random variable which is x, and x is 1. If the probability of x happening is a success, and x is 0 if it is a failure. If we define this as the success and the failure, we can use something known as the Bernoulli function to describe. The Bernoulli function, it carries the idea of binomial as well. But the Bernoulli looks at multiple, the binomial looks at precisely 2. Let's take it. So the probability of failure is 1 minus P. The probability of success is P. Now watch it, the probability of failure has been given by 0. The probability of success has been given by. Oops. So with this, you should be able to understand something related to binomial formula. But I've already told you that every random variable, listen, you need 2 things from the random variable, the mean and then the variance. And you can just take the square root of the variance to get to rather than standard deviation. So the question is that in this binomial, what is the mean? Guys, the mean is simple. The mean is simply the probability of success. Take note. So once you know the probability of success, it is a mean. It's simply P, and P is the probability of success. The variance is the probability of success multiplied by, watch it, is the probability of success multiplied by 1 minus the probability of success. That's the variance. And of course, taking the square root of that to give you the standard. Cool, right? So now, let's see whether I can get something. Yes, Irama.
Please, can you go over again?
Normally, I've observed that when you people want me to go over again, it's because the formula is not clear, isn't it?
Yes.
But when we start with an example, then the formula is clear. So I'm going to just give you a typical example, and you see that the formula is very, very straightforward. We'll talk a lot about this. So let's take an example, a fixed number of observation. These are what we call the properties of a binomial function or the Bernoulli function. You have a fixed number of observation. The observation is the sample size. So for you to be able to use the binomial distribution, there must be a fixed number of observations. For example, suppose you have 15 tosses of a coin. The number has been given 15 tosses, so it's fixed. It didn't say tosses of a coin. No, it's 15 tosses, fixed number. 10 light bulbs taken from a warehouse. The N is what? 10. The next thing aside the fixed number of observation is the 2 mutually exclusive and collectively exhaustive categories. I'm sure you guys remember that from last time. 2 events are mutually exclusive, joint, and collectively exhaustive. So a typical example here is a head or a tail in each toss of a coin. That's you see, the two cannot meet. You can't be a head and a tail at the same time. The next one is defective and not defective light bulbs. It can't be defective, then defective. These are simply the success rates. You know this all. And finally, not finally, there's a constant probability for each observation. So the observation that you are spoken about, if it is 15, is 15 throughout. The probability attached to each one is the same. So in the toss of a coin, the probability of failure is how much? Who can tell me? If you toss a coin, the probability of the coin being a head is what? Amma?
0.5.
0.5. And the probability of the coin being a tail is what? Amma?
The same 0.5.
Exactly. What we are saying is that this probability must be constant. It shouldn't change. So you can't get to another time when somebody is tossing a coin and say now the probability of, no, it is fixed. It's constant. It's the same every time you toss it. The observations are not dependent on each other. Okay? In other words, the results don't affect the outcome. An example will make all of these clear. So let's take a typical example. So these are possible situations where binomial can come in, but also there can be possible situations that are not binomial. Let's take a typical example. A firm bidding for contract, we either get a contract to be yes or no. Who can give me a scenario of binomial, a binomial setting? Who can give me one example? This one, everybody should say so. Stella.
Say a man proposes to a woman, it can be a yes or a no.
Life, no one. Very good. Next one. Theophilus.
So please, the gender of a human being could either be male or female.
Depending on where you are, isn't it?
Precisely, yes.
What else? Can be. Rama.
Yes, sir. Hello.
Yeah, go ahead.
Yes. When you run a medical test, it could be negative or positive.
Very good. Amina.
So she just said my own.
Okay. She said your own. Okay. Who has another one? Esnam.
Your tea can either be hot or cold.
Warm. How are warm? When they are saying give one that nobody will argue. Venice.
So please, a test outcome. It can be a positive one or a negative one.
Okay, somebody has said it. Gawker.
Sir, please, it's either your light is on or off.
Very good. Magni. Let's go to Wallace.
Sir, please, it could be day or night.
Or dawn.
Light or dark.
Light or what? Dark. Or in between.
Day or night, light and darkness.
We have understood you. Hanan.
True or false?
Very good. So these are some of the examples that you can think all the time. These are clear. All right. So now write the binomial formula down. Everybody, please write it down. This is the formula you need to be able to understand, calculate, arrange each binomial situation. When you're able to write, please raise your hand. Write it down in your book. When you're able to write it, let me know. I want to be sure that majority of you. There's a deliberate reason why I want you to actually write it. You'll understand very soon. Okay, very good. I've got a good number. What does let's start with the N. What does the N stand for? The N for no. Please lower your hands. What does the N stand for? Nanaya. Portia. Portia, what does the N stand for?
So the N could be the N is the total number of maybe trials.
Total number of trials of the observation.
Yes. Or maybe attempts or shots or whatever.
Very good. Very good.
Mm.
What about the exclamation mark? You can tell us what the exclamation mark is. Exclamation mark. Enoch.
So the factorial.
Very good. What does that mean? Give me an example. What is 1 factorial? Don't say it. Look at your calculator before you say it, else you get it wrong. What is 1 factorial? 1 factorial. Yes, ma'am.
1 times 1.
Are you guessing? The way you said it, it's like you are trying to see whether it's true.
From what I remember,
No,
I think.
I said you should use your calculator. Use your calculator. And tell me, what is 1 factorial? I know you are right, but okay, that's good. So 1 factorial is 1. What is 0 factorial? 0 factorial. Oh, by the way, when we say 1 factorial, we mean something like this. 1 factorial. That is 1. What is 0 factorial? Don't copy from anyone. Emmanuel.
So it's still 1.
Very good. What is 2 factorial?
2.
So how do you get a 2? 2 factorial is equal to what?
2
times
1.
What does that mean? What are you doing here? So what is 3 factorial? Guys, follow me here. How do you get 3 factorial? Don't give me the answer. Nanama.
3 times 2 times 1.
3 times 2 times 1. What is 4 factorial? What is 4 factorial? Cameo. What is 4 factorial? Venice.
Okay, so 4 times 3 times 2 times 1.
Very good. What is 5 factorial? 5 factorial. Theophilus.
Sir, please, 120.
No, I don't want the answer. What is 5 factorial?
5 factorial, that is 5 times 4 times 3 times 2 times 1.
Very good. So I'm sure you all understand what a factorial is. It's very important to know. So P here is a probability of success, and then 1 minus P is the probability of failure. The most important difficulty with the binomial is what is known as the X. The X can change. Most of the things can change, but the X is the one that can change. What is X? Watch it. X is the number of successes in the sample. It can be any number. Stella.
Sir, sorry, sir. A question. With the factorial, I had no idea of what a factorial. I just learned it. But then I'm wondering what the 0 factorial, why we got 1 for 0 factorial.
Why 0 factorial is equal to 1?
1, yes, sir.
It's a wonderful question. And a lot of people are usually confused. Now, factorial is actually defined as this. Let me just give it. It's defined as n factorial. And this is, you're going to get confused, but I hope you are not. This is equal to n times n minus 1, the close bracket, times n minus and n minus 2 times just a second. N into brackets n minus 2. And then you have times, well, somebody's calling me unnecessary. And then this will continue. Continue. So there's a pattern here. Watch the pattern. Watch the pattern. Suppose I tell you that 3 factorial, you're going to tell me that it is 3 times 2 times 1, isn't it? 2 factorial is going to be 2 times 1, isn't it? 1 factorial is going to be what? 1. So watch the pattern. Watch the pattern. Here you're going to get 6. Here you're going to get 2. Here you're going to get 1. If you go a step lower using the rule, what's going to happen? N factorial, okay, is going to be n times n into brackets minus 1. N minus 1. This is a rule. This is a rule. Factorial. So if n is 1, what do you have? If n is 1, if n is 1, if n here, this is a rule. If n is 1, so n factorial is equal to 1 factorial, what do you get? You're going to get 1 here, then 1 minus 1, then factorial. So watch it. This is 1, n minus 1, this is also 1 already, isn't it? So you have 1 minus 1 giving you what? Somebody follow me. 1 minus 1 here will give you 0.
0.
0. And now there's, what is here? 1. Right? But then this 0,
1.
Yeah, this 0 is a factorial. This 0 itself is a factorial. So when you have 0, the whole of this 0 is a factorial. And then you now have 1 multiplying 0 factorial. Using the rule of 1, this is going to be 1. You see, you told me that is 1, but you didn't really know why that was 1. So you are actually going to get 1 times 0 factorial. And what is that? 1 times 0 factorial is equal to 1. Check it. Use the rule. Check it. Because you didn't use the rule, but when I asked you what is 1 factorial, you told me that 1 factorial is 1. By using the rule, it will actually be 0 factorial, isn't it? It will be 1 times 0 factorial, which means that is 0 factorial, which means that is 1. That is why 0 factorial is 1. This is combinatorics. Is that combinatorics? So at least you asked the
They're in the class, but I'll come down.
Yeah, that's why I said that you shouldn't ask. By using that rule that I gave you, this pattern of rule is what we use to do. The most important thing I'm interested in you guys getting, because this is practical aspect, is the successes. The number of successes in the sample. So you remember the sample is n. And out of this n, you pick an x. X is the success. X can be any number. It can be 0, it can be 1, it can be 2. It can be between 0 and 1. It can be above 1. It can be below 1. It can be below 6. It can be above 6. It can be between 6 and 7. X is the main giant. That will be changing. Remember the definition of X is a number of successes in the sample. Now, when I say successes, I don't mean positive. It is simply the number of successes in the sample. I do understand. Next, So now use this factorial, this formula here, and let's calculate. We'll use this later on to calculate some question. As for the P, we know the P is the probability of success. Let's take a quick one, a quick easy one. Let's flip a coin 4 times. Flip a coin 4 times. The moment you have this, the first thing you have to ask yourself is some terminologies. If you flip a coin 4 times, you got to find out the N, find out the P, find out the 1 minus the P, and finally find out the X. That's what you have to do. And then you have been told that X is the number of heads. So first thing you want to do is to find out the sample size. In this question, what is the sample size? It's easy in the question. What is the sample size? What is the N? What is the N? Oh, Stella.
Say 4.
It's 4. It's 4. It's right there in the question. So we know that N is 4. Always try to find the elements of what you're looking for. What is P? What is P? And who can tell us why? Why you chose that? What is P? What is the probability of success? Remember, flipping a coin 4 times. It is embedded though. The P was not given to you, but it's assumed. It's already intrinsic in the statement. Stella.
Say 0.5.
Why?
That one will be difficult to explain.
Yeah, if you can't tell me why you did lottery.
So, yes, I got it from the explanation a mate gave some earlier on. The 0.5, the probability of success is 0.5, and the probability of failure is also 0.5. That's how I got mine.
I think I got someone else to also give us a read.
Yeah, because the probability of success is equal to the mean. And so in this case, the mean, the average number of times that the head will appear is 0.5. So that is why P is 0.5.
Manama, thank you. Manama.
So I think sorry. So I believe that the probability of getting a head or a tail are the same. And then the possibility of getting a head plus the possibility of getting a tail is supposed to be equal to 1. So if they are the same, then 0.5 plus 0.5 is equal to 1.
So when you toss a coin, when you flip in a coin, the chances of, there are only 2 possible options. Getting a head or getting a tail. And since there are only 2 possible options here, getting a head, the chances of getting a head is 50%. The chances of getting a tail is also 50%. That is why the probability of success, which in this case, a head, is 50%. Okay, what is 1 minus P? It's also 0.5. Now, here it comes. You are told to find X. And X is the number of heads. So based on this, you're going to find the number of heads. What are the possible ways of finding the number of heads? The number of heads can appear how many times? Many times, right? Head. It can happen many times. So X can be what? 0. Okay? Because when you throw it 4 times, the chances that there will not be any head. So that's 0. When you throw it twice, the chance of getting a head is also not there. So you can throw all of them 4 times, there will be no head. You can throw it all 4 times, the head will be 1. You can throw it 4 times, the head will be what? 2. You can throw it 4 times, the head will be 3. Or you can throw it 4 times, all 4 times. All the 4 times, they were all head. The chances of you getting a head is going to be 0 all the way up to. It's a very tricky one, but that's how you calculate for this example. Okay, but that is not using the formula. Now let's use the formula to find the real scenario. Anytime you have a probability, use a symbol. So look at the question here now. What is the probability of 1 success in 5 observations if the probability of success is 10%? Watch it. The first thing you got to do is to find your N, That's the first thing. Find your n. So what is the n here? What is the p here? What is the 1 minus p? And what is the x here? Quickly, who can tell us the n in this question? What's the sample size? Question was, what is the probability of one success in 5 observations if the probability of success is 0.1? Yeah, can be. Jessica.
It's 5.
It's 5. What is p? What is p? It's given. It's there. Portia.
Sorry, my mic was 0.1.
0.1. What
Yes.
is 1 minus p? Stella.
0.9.
0.9. Very good. And from the question, what is x? This is a tricky one. Hannah.
So it's an old handle.
If it was money, would you have said it's an old hand?
So I've not had the chance to look at it. So I can't.
Is there? What is x? Stella.
Is that 0, 1, 2, 3, 4, 5?
No. What is x?
Okay.
It's there. P-eyes. Portia.
So that would be the number of successes we want.
What is x?
5.
Let's go to Emmanuel. What is x?
Is it 1?
Are you asking me or you're telling me?
I'm telling you 1.
This one. Look at it. It's right there. You didn't take it. You know you didn't find it. What is the probability of one success? Remember, okay, I told you that the success, the number of success is 1. I mean, the number of success is x. And x has been given in this person. We are told 1 success. Okay. Now, you substitute it into the formula of the probability that you found. Substitute it and tell me your answer. Substitute and tell me your answer. If you substitute this into the formula, watch it. I'm going to put it all into this one. Okay. You have each of the elements. You substitute it all into the formula. You will get 32.81%. Guys, I've just given you the answer. Doesn't mean that you should not calculate. Because it is through your calculation that you will know that you are wrong. I've seen this. I just want you, because the next ones I'm going to let you calculate. And I just want you to know that it is through your calculation that you know that you are right or you are wrong. So please note that carefully. Note that carefully. Any question? Any question at all? Fantastic. Next one, I'll let you calculate. When you are calculating, remember that some of them have got exponent. Yes, Valentina. Valentina, your hand is up.
Yes, sir. Sir, please, just a little clarification on the factorial. Looking at what we did, is it that the factorial has to, if we are looking for a factorial of a particular number, it means that we are multiplying the number by all the integers that are less than the number.
Correct. And
excluding 0.
Yes, when you get to 1, you stop. You don't go to 0.
Okay, sir. That's all I wanted to find out. Thank you.
So now let's go to another example here. What is the probability of getting exactly 2 tails? Watch the word. In 3 tosses of a coin. Question here is that, is this binomial or Poisson? Well, since we are doing binomial, you know that it's binomial. Now, what makes this a binomial question? You can tell us. There's something in this question that makes it binomial. What is that? Stella.
Sir, the fact that it's a coin and you can just get a head or a tail.
Perfect. Excellent. I'm going to be giving some marks today. for those that are participating a lot. So take note. If I don't remember you, it simply means that you have not been participating enough for me to remember you. All right. So now we know it's a binomial. Now that you know it's a binomial, write the binomial formula down. And let's find the n. Let's find the p. Find the 1 minus the p. And identify the x in this purpose. So what is n here? What is n? Write your binomial formula. Vanessa.
There is N3.
N is 3. What is p? What is p? Portia.
0.5.
And 5. What is 1 minus p? Portia.
1 minus p, that would be same 0.5.
Very good. What is x?
X is 2.
X is 2.
Yes,
Now,
we want
how do
to
you write
x-axis. Yes.
Very good. How do you write x? Remember, x is, you write it as probability of success. And the success is x. And it's either going to be x greater than 2, x less than 2, x greater or equal to 2, x less or equal to 2, or x equal to 2. Which one? Which one? And why do you say so? Which one? And why do you say so? Amina.
So I think it's x equals to 2 because it says exactly 2 tails.
Exactly. Exactly. That means you learn it. That word exactly. But if the question has been, what's the probability of getting no more than 2? No more than, then you know there are going to be changes to this. But let's now do x is exactly 2. So I want you to use the binomial formula, and then with this element, find the probability of finding exactly 2. If you are done, raise your hand. If you are able to get them, raise your hand and tell me yes. Raise your hand and I'll call you. In fact, you can even WhatsApp me privately your answer. Start with your answer. Okay. So I've got an answer from Nanaya. Nanaya, can you tell us?
Yes, sir. Please, I had 0.375. Sir, please, I also want to ask a question. Can it be written in a fraction form than just the decimal?
Use the decimals.
Okay, sure.
Okay. So I'm sure you all had that answer she just gave. The answer is correct. And I saw the hands that actually were raised. Clear indication that I hope that you guys did the right thing. So This is a clear way of solving it, and you should get 37.5%. So the chances of you getting exactly 2 out of the 3 is just small, 37%. It's not even up to 50% chance. Remember, probability is a chance of an event. A chance of an event. Okay. Yes, Namte, Emmanuel.
Yes, sir. So I remember you asked if the question says that getting exactly if you had changed the question say not less than 2, in that instance, how will we pick the x?
If the question has been probability of x being no less than 2, watch the word, no less than 2. If you have no less than 2, first of all, you should know less than 2. Less than 2 means this symbol. So no less than 2 is the opposite of this symbol, which means it's greater than 2 or equal to. It's not just greater than, it's greater or equal to. So note that. The opposite of less than is not greater than. The opposite of less than is greater or equal to. So no less than 2 is greater or equal to 2. So now how do you solve that? Greater or equal to 2 means that you are first going to, this equal to means 2 is part. So you're actually going to calculate the probability of x being equal to what? 2, add it to the probability of x being equal to 3. And remember, there were how many tosses? 3 tosses. So you don't go more than what? 3. So now you're going to calculate this probability, calculate that probability, add them together, and that gives you the final answer. As for solving the probability that x is equal to 2, we just did that. So you have this 37.5. Okay. You do for 3, you just change whatever you have to put 3 there. And I mean, whatever you have to for the x. So x changes from 2 to 3. And then you can add the 2 together. Anna?
So please, if it's no more than 2, does that mean that you also do equal to 2 and equal to 1 and you add them?
Exactly. No, that one you start from 0. So you do equal to 2, equal to 1, and then equal to 0 when you add them.
Okay.
So when it is below, remember to include 0. All right. Let's take an example. This is example 3. The reason why I'm giving you more examples is that example is more efficacious than precept. Hisense Ghana produces and sells HD TVs. Now this is tough, but you can do it. The HD TVs are inspected at the end of the production process at a quality control station. Out of every batch of HD TVs, 4 are randomly selected and tested for defects. Yes, they are tested whether they are bad HD TV or they are not. Given that 20% of all batches are defective, what is the probability that each batch of HD TV will contain exactly 2 defective HD TVs? Is this binomial question? Well, since we are looking at binomial, obviously it is. But who can tell me why this is a binomial? Because the ability to tell me that why is more powerful than telling me the why. The why is more important. Why? Emmanuel. Emmanuel, yes.
So with this one, the batches of the tellies can either be defective or not defective. So then the outcome of it is true. So it makes it binomial.
Excellent. Guys, if you don't understand, you can repeat. But this is a skill because once you learn binomial and you also go and learn Poisson, you can be confused. So you need to master the trick of it. Good. Now let's go to the next part. The next part after identifying that is binomial is to identify your n, your p, your 1 minus the p, and then your x. So what is the n here? Who can tell us? Raise your hand and tell us what is the n, Portia.
So the n will be 4.
N will be 4. Number.
Yes.
Who can tell us the p? Who can tell us the p? Andrew.
0.8.
That's the p.
Yes, sir.
Have you eaten? Papa Andrew, have you eaten? Hanan?
0.2.
0.2, not 0.8, but rather 0.2. I actually don't know why you said 0.2. There may be a 0.8. Is there a particular reason why you chose 0.8?
So because I was using the 20% as the failure, which is the defective. So the difference would be 80%. That's why I said 0.8.
We're calculating defective, and it says that 20% is defective. Our interest is to find defective, and 20% is defective. So that is a probability of success. So the defective is the probability, is the number of success. The 20% is the probability of defective items.
Okay, does that mean in this case the failure will be the 8, right?
Exactly. I just want you to remember that I told you that don't use the negative to represent success, to represent failure, and the positive to represent success. So maybe because you saw defective, and defective is bad.
Yes, sir.
But don't attach morality to it.
Okay.
All right. So 1 minus p is the 0.8. Now from this question, what is the x? What is it? It always usually comes from within the question. So this is usually the top part. Valentina.
X is 2.
What makes you say x is 2?
So because the question says that what is the probability that each batch of the HDTVs will contain exactly 2 defective HDTVs? So exactly 2.
So what symbol is that? That exactly 2. What symbol is that? Hanan.
So that's P bracket X is equal to 2.
So the symbol is equal to. That's what I'm making. The symbol is equal to. So guys, that is a symbol. Now that you know that is equal to 2, you just substitute it, then fine. You are not going to add or subtract anything. Just calculate. But that's not the only question. So if you now you know how to calculate. So let me show you that. So if you do this, you're going to get to this value for exactly 2. So the probability of getting exactly 2 defective items out of the 4 is 15%. You stand no chance. But look at the next part of the question, still continuing. It says that find the probability of less than 2 defectives. How will you write it? You write it as P what? The probability of less than 2 defectives. What would that be? P into bracket X what? Something 2. What is that? Yes, ma'am.
Less than 2 defectives. It's less than 2.
So what symbol will you use?
Less than.
Now that less than 2 then will mean that, remember, there are how many trials? The sample size is what? 4, right? The sample size is 4. So how many probabilities do you have to calculate to find this answer? How many? How many probabilities do you have to calculate to find the probability of x less than 2? Anan?
2.
What are they?
Probability of 0 and probability of 1.
And then you do what?
You add them.
You add them. Excellent. Very good. Okay. Guys, note that. This is very important. We are not going to calculate that. Okay. But let's look at the next part of the question. It says that if 2 or more defectives, let me just clean this. If 2 or more defectives are found, the whole batch will be rejected. If 2 or more, the whole batch will be rejected. The manager wants to know the probability of rejecting an entire batch if, in fact, the batch has 20% defective items. This is a bit tricky, but it's still easy. So how do you handle this? If 2 or more, how will you find 2 or more? The whole batch will be rejected. Yes, enough.
So that means you have your P to be equal to X greater than or equal to 2. So you find that means you have to calculate 3 probabilities, 2, 3, and 4.
Yeah.
So then
Now,
you sum it up.
Very good. Now, guys, watch something. It says you have to calculate the probability of X equals to 2, probability of X equals to 3, probability of X equals to what? 4. And then sum them. He's right. But that's a long way. Smart way, you can cut short. Because this whole probability and every other thing add up to what? 1. So you can say that instead of this and adding, you can rather calculate, you can find the probability. You see, this probability of 2 or more means is the same as probability of, watch it, is a probability of X being less or equal to 1. Do you realize that? 2 or more. If you tilt it the other way, this opposite is 1 or less, isn't it?
Yes.
Excellent.
Yes.
So
Yes,
you can
that's
rather
true.
say that, let me rather calculate this and subtract it from 1. I'll still get the same answer. So you can say that this would equal to 1 minus, the probability of the 2 or more, which is X greater than 2, this one, is 1 minus the probability of X being less or equal to 1. Yes. And you've already calculated probability of 0, probability of 1. So here you just have to calculate 2 of them. So just calculate probability of 0, probability of 1. Whatever you get here, you subtract it from 1 because probability add up to 1. And that will still give you this answer. So whilst your friend is going through 2, 3, 4 and struggling, you just calculate 0, 1, subtract it from 1, and you get the same thing. It's cool, isn't it? It's really cool. This is when you understand.
Confused.
You are confused. Have you eaten?
Sir, please,
Yes,
I'm
Say a question.
Go ahead.
Say, you know, from the question we calculated the P into bracket X less than 2. Can we use that one instead of, can we denote that one as the P into bracket X less than or equal to 1? Is it the same as that one?
Yes, that's the same thing. We calculated this one. Okay? So that's the same thing as this. So, but remember that this question is the C part. So you would have calculated this part before you come to that one. I don't know if you understand.
I understand, sir.
I decided to do it first. So yes, you can just take what we did before, subtract it from 1, and that gives you this one. Now somebody says that they understand. But do you understand this first part?
Yes, please.
Do you understand this first part?
Yes,
Sir,
sir.
that's why I got lost.
Yeah. Where your friend said to get 2 or more, you should just calculate the probability of X being 2, X being 3, X being 4, and adding them. Are you lost with that one too? No question means that No answer. Response means you understand.
No, sir. Please run that one again.
So the question was, find the probability of 2 or more. That's it here. 2 or more defective. So 2 or more defective, you just find what? 2 or more defective simply means you are finding probability that X is greater or equal to 2.
Greater, equal to 2. Yes.
That's 2 or more. And that means that you need to
Yes,
find
sir.
2, 3, and then 4. Then you add them, you are done. And I'm saying that that is good, but it's a long way. Why is it a long way? Because you should know that this one you have here, that is 2 or more, is 1 minus 1 or less. 2 or more is the same as, you see, this 2 or more is the same as 1 minus X being 1 or less. And that's true. Because remember, you have 0, 1, 2, 3, 4. Okay? So if I do 2 or more, it's the same as less than 2 or 1 or less. So instead of calculating 2, 3, 4, just calculate 1 or less. That is, calculate 0, calculate 1. Then whatever you have found, you are going to calculate the 2 probabilities. Once you find that, you subtract these 2 answers. You would have gotten 2 different probabilities. Subtract both of them from 1, and that will give you the same answer here. Let me show you something. So this is 2 or more. So 2 or more, you see you did the 2 here, 2 here, you've done 2 here, you've done 3 here, you've done 4 here. What are you doing? You're adding them, and that gives you this.
Oh, okay.
That's what this gives you. Now, you can now calculate 0 or 1, these 2. And when you calculate 0 or 1, what do? Oh, I made a typo. When you calculate 0 and 1, you will have this. That's what you have. If you like, you do it. When you calculate 0 and 1, you get this. And once you calculate 0 and 1, you can now subtract it and you get the same answer as this. I wrote it slightly different. Okay, I was just calculating less than 2, but you see, less than 2 is the same as 0 or 1. Okay. But I just equated it, but I didn't calculate it. So this one should come here, and then the less than 1, the 81.92% should rather come here, and then this one. And again, when you go and check 81 for 0 and 1, you get 81.92. And then you subtract that from 1, and you get the same thing as 2 or more. Okay, Amina, your hand is up.
Yes, sir. Please, I'm not taking us back, but I'm looking at the calculation for the P equals to X equals 2 defective. And
Yeah.
I'm seeing that, yeah, we've written 4 factorial over 2 factorial into brackets 4 minus 2 factorial. And the next line, you come to do 4 times 3 times 2 times 1 over 2 times 1. Yes, but 4 minus 2, I'm seeing 1.
4 minus 2 is 2.
Yes, please.
Yeah, it's 2. So
Yes,
you.
but I'm seeing 1.
Oh yeah, it's a typo. It's a typo. The answer was still the same, but I think it's a typo. So it's 2 factorial times 2 factorial. That's how it's going to be.
Okay. Thank you.
If you work it, you will see that it was a typo, but the answer is correct. All right. So that's it. Now we can finally find, yes, Bernice.
Sir, please, a question. So for the question C, which is find the probability of less than 2 defectives, are we still going to use the same probability of X equal to 2 defectives formula to solve it? Because that's where I'm getting the confusion.
Are we still using what?
Are we going to use the P is equal to 2 defective formula to also calculate for the probability of less than 2 defectives?
Okay, so if you are going to find the probability of this one, are you talking about this one here? Or the 2 or more?
Yes, sir. Yes, sir.
This one?
The less than 2 defectives.
Oh, but this one,
yes, please.
Done it long ago. Less than 2 defective is finding this one here. Okay, less than 2. That means 0 and 1. So finding this probability of x is equal to 2. And you see, because I worked this one before I came to the other one. Yes, because previously, I should have worked this one first. Like I said, I should work this one. And this one is this, isn't it? That's the one on the left here. 2 or more, that's the one on the left here.
Yes.
Then it comes to tell you that find the probability of less than 2 defectives. Because I had already calculated this, less than 2 defective is just the opposite of what I did here. Less than 2 defective is just the opposite. So now that I already know the 0.1808, I just subtract that from 1 and it gives me the less than 2 defective. That's all I did.
Oh, great.
Okay. Okay. Thank you.
But if you had calculated this one first, then you will rather get this 0.8192 and rather subtract it from 1, and that will still give you this one. Now, finally, remember that every every discrete random variable and this probability distribution, you need to know the mean and the standard deviation. So what is the mean? We've said it before, we are finishing our point of it. The mean of the binomial distribution and the variance of the binomial distribution are as follows. The mean is given by the sample size times the probability. That's the mean. What about the variance? The variance is given by the sample size times the probability of success multiplied by the probability of failure. So it's simple. So let's look at this quick example here of finding the mean. Suppose you have x to be 1, n to be 5, and then the probability of success to be 10%. We've used this thing already. What would be the mean? This one, you can just look at it and tell me. What would be the mean? Use a calculator. What would be the mean? Who can tell me the process? I mean,
You multiply the sample, the n, by the probability, which is 0.1. So it would be 5 times 0.1, which will give you 0.5.
That's it. What about the standard deviation? You take that 0.5 and then multiply that by what?
We take that 0.5 and multiply it by 1 minus p.
Hanan, tell us.
Okay.
So you take that 0.5 and then you multiply it by 1 minus p, which is 0.9 in this instance. So 0.5 by 0.9 will give you 0.45.
Very good. Very good. That's it. So that is how you undertake this. In fact, everything you said is here. If you want, that will give you the variance. If you want the standard deviation, you just find the square root of that answer. And when you find the standard deviation, it will be the square root of the variance. And that will give you 67%. That's how you find the mean, the standard deviation of a binomial. This is a variance, by the way. The variance was 2.5. The standard deviation is 67.6708. All right. There are several characteristics of the, for example, if I change the sample, suppose I change, watch the way this graph is. You see the probability is 0.1. The sample size is still 5. The sample size is still 5. It has not changed down here. But the probability has gone up. The moment the probability goes up, you can see clearly that the thing is becoming normally distributed. Otherwise, here it is becoming right scale, okay, positively scaled, positively skewed. Okay, so you see that the top one is positively skewed because the probability is low. As the probability increases, symmetric is obtained, and then finally it goes to negatively skewed as the probability of success reaches from it. So this tells you how the whole thing changes possibly. Ladies and gentlemen, that brings us to the end of the entire tableau. I'm sure you've gotten some stuff. Yes, Elena.